Hello, this is Ben and Jim with DC Digital, and today we're demonstrating a custom counter number display with a keypad and a sensor, and it's a polarized reflective sensor that's going to count specific operations for this customer. And the idea of the keypad is to set upper threshold or upper limit of the count, and then when it reaches that count, it will activate a relay and then stop to allow the customer to reset it or do some kind of action. And also we have this is a master over to the right, and this is a secondary, which would be redundant of whatever is being shown on the master. So this could be somewhere else in the plant where they're going to be monitoring the count for the personnel. So without further ado, I'm going to have Ben show and demonstrate how to set the upper limit and the operation of the keypad and the functionality of the counter that he's developed. Ben?
Thank you, Jim.
You're welcome.
This is a counter that is used in a durability testing lab. So they are hammering various parts for a number of cycles, and they want to hammer that part several thousand cycles and get the count on the display, and then as it reaches those number of cycles, then cuts out the machine. So there are some features then in here that make sense for that purpose. The reflective sensor is to detect the hammer that is going up and down to hammer the part. The relay is to kick out the machine, the hammer, from continuing to operate after it's reached its top cycle. The keypad is to set the top cycle and also operate the counter.
Let me get a close-up of that, Ben. Go ahead. Oh yeah, there you go. That's very good, thank you.
Okay, so you'll see there are buttons 1 through 0. They're number buttons. Then there is a set or view max count, an enter button, clear, and run/pause. So right now, the sensor, despite the fact that it fell down when I moved it,
The reflector.
It'll
stand up on that. There you go.
It won't do anything because it is not in run mode. It is currently out of run mode, and that is indicated by the dot in the bottom. Okay, so run and pause will enter that run mode, allowing the hammer to operate the sensor. Exiting that run mode will prevent the optical from working at all. Before you can start, you need to set a max count. You do that by hitting the set max count button. Right now we have it set to 5. We'll go ahead and set it to 10 using the keypad and hit enter. Now we need to put it in run mode, and then as we pass the hammer through several thousand operations, once we reach 10 cycles, you heard the relay go off, or maybe you didn't, and it won't go any further. We can then clear that and repeat the process, or we can go into setting a new process.
Max.
A new max, correct. It'll kick us out of run mode and zero it out, so we'll need to re-enter run mode. And now our new max is 5. Or we can also exit from there, the run mode, and it'll zero it out as well.
But you got to hit run again for it to activate. So
to go back in, you have to go to run. Now, our max value is indefinite. We don't have to reset the max each time unless we want to change it.
That's held in non-volatile, right?
Yes, it's also held in non-volatile. So if power is unplugged, it'll continue to keep that number.
Well, let's say they get to 3 and they want to pause it or work on the machine.
Sure.
And maybe they may trip the sensor or something by accident. How do you turn that off, or how can you interrupt it and not?
So the machine's running and then there's a problem with the part.
It's not hitting the reflector. There you go.
We can exit run mode,
Now you can
fix what we were doing without interrupting our count, enter run mode again, and get back up to our count, and continue on to our count. Or we can if we exit, we can also view what our maximum count is without affecting our count. We can reset to 0 if we need to, if we need to restart from the beginning. And we are out of run mode. So there we go.
Very good.
Given the nature of the durability testing machine, the anvil, going up and down, and depending on where the photo eye is placed, it can require one of 3 scenarios. If the photo eye is placed at the top of the anvil so that it is only breaking the photo eye at the very top of its upstroke, then it can count every single time. And that is set by dip switches inside the timer here. So in the position where all of the dip switches are off, it will count every time. You want to demonstrate
Sure.
that? So you'll see as his hand passes through there, it's counting every hand passing in both directions.
So we're breaking the beam every time. It passes in either direction. Okay.
Okay. So now if I set dip switch number 3 into the on position, I'm going to go ahead and zero it out so that we're starting from the start, and you'll notice that it skips the first one and counts on the second. So that means that it would skip on the down and count on the up stroke. Okay. And I'm going to do that again. I'm going to turn off dip switch number 3 and turn on dip switch number 2. And I'm going to go ahead and zero it out. And now you'll see it counts on the first stroke, on the downstroke, and skips the upstroke. And so this allows them some flexibility as to where they place the sensor and how the anvil is detected as far as the number of counts.
And then internally there's another 485 connection and also terminal blocks for your sensor, and that's all well marked, and then output to your secondary, and then all these are modular connected so you can separate the front from the rear, and then our relay output 1, 2, and 3, and then our interface board to operate the sensor is also mounted on the back plate, and then you can enter wire from the back, center of the back, or the left side if you want to add your cabling connections there or your conduit. It can be hung on a 4-square or handy box, and there's keyhole knockouts for that. And this is all aluminum enclosure. You have a 4-inch high display. Any one of our size displays will be able to adapt this to that. So if you wanted a smaller display, we can do that. If you wanted a larger display, up to 30-inch high digits, we can adapt it to that. So again, this is Ben and Jim with DC Digital, and we're demonstrating a custom project for a counter that we developed that sets the max value to operate a relay and give the customer the option to have a relay activation at a max value. Thank you for watching.